Okay, so again, topic for today will be shear and moment. No? First is shear and moment, then I will be introducing the shear and moment diagram. Start muna tayo sa concept, which is the shear and moment. Okay, so ang definition ng shear is, it is the net unbalanced vertical force acting at the exploratory section of the left or right section of the beam. Ang moment naman is, it is the net unbalanced moment acting at the centroid of the exploratory section of the left or right section of the beam. Ano ba yung exploratory section na tinatawag? Okay, so if you have a beam, no, etong example natin, about any point on a beam kasi, kunyari, ito yung beam, no, from point here to this point, about any point dyan sa beam, kapag mag-cut tayo, there is an internal shear and an internal moment present. So, ang shear force, it is a vertical force. So, ang direction lang niyan is either upward or downward. Ang purpose ng shear is para ma-balance yung section. Bakit? 'Di ba? If you recall in computation of your reactions, ang ginagawa, anong purpose ng reaction? 'Di ba? Ang purpose ng reaction is para ma-resist ang vertical movement. Similar with the internal shear, no? Kasi kapag ikakat natin yan, kunyari mag-cut tayo sa portion na to, yung internal shear, yun yung magbabalance dun sa section. What do we mean by balanced? Ibig sabihin, the summation of forces vertical, kapag i-add natin lahat ng forces downward and lahat ng forces upward, they should be equal to 0. So all throughout the beam, that should be always be the case. No? Para masabi natin walang movement present sa isang beam or sa isang structure, kailangan at about any point pag nag-cut tayo, yung summation of forces vertical, yung summation of moment, tsaka yung summation of forces horizontal, lahat sila dapat equal to 0. Kasi kapag hindi yun equal to 0, ibig sabihin meron tayong movement. Ulitin ko, ang purpose nito is for equilibrium or for the structure to not have any movement. Kasi kung sa actual naman siya, no, kasi this is theory, kung actual siya, supposedly may beam, no, I hope you know what beam is na. Ang beam, kapag hindi dyan 0 yung force vertical, so magmo-move siya, either upward or downward. So gumagalaw yung beam. So that should not be the case. No? Dapat walang movement. So ito yung theory behind that. Everything should be equal to 0. No? So yan, definition ng shear, yun yung vertical force about any point sa structure. Yung moment naman, siya yung moment about any point kung magkakat naman tayo ng any type of structure. So yun yung definition niya. So we also have what we call your shear and moment equations. Now, as the name suggests, no, equation, so these are developed by passing exploratory section at a distance x. Tapos gagawa tayo ng equation. So, ang shear and moment equation kasi, ilan ba yung equation na possible sa isang beam? Ano natin malalaman kung ilan yung equation? Kasi 'di ba, sa algebra pa lang, no, pag sa isang structure, pwede tayo makakuha diyan ng algebraic expression. Same with your shear and moment equation. So, kung sa isang beam, ilan ba yung equation na pwede nating makuha? So, ang madaling way din para malaman nyo kung ilang portion ba or ilang equation yung makukuha natin, titingnan nyo siya as a segment na tinatawag. So, ito, example to, no? This is a single beam. Isang beam, tapos meron siyang uniform load, concentrated load, tapos uniform distributing load. So, yung number of equation, naka-equate na siya dito sa mga hati-hati. Ito yung exploratory section. So, dito meron tayong 1, 2, 3, 4. If we are to consider this beam, we need 4 equations. So, paano natin nasabi na 4? Ganito yung gagawin. So, here kasi, kung mapapansin nyo, this is a uniform load, no? Itong part na to. So, this is one segment. Tapos ito, isang segment din to. Paano natin nasabing dalawang segment sila? Because there's a concentrated load present, ibig sabihin, nahati siya sa gitna. Nahati siya dito sa portion na to. Ang reason ng pagkahati is the concentrated load. So, ang ating segment is ito, one segment, second segment. Another segment is this one here. Ito pa, isang segment. Bakit? Kasi wala siyang load. Ibig sabihin, at this point, nahati yung distribution ng load. So, ito yung pangatlo, tatlong segment. And then, pang-apat, ito ng uniform load. So, all in all, we have 4 segments. Now, paano natin malalaman kung saan tayo magka-cut? Kasi tingnan nyo, meron tayong 1, 2, 3, 4. So, how will you know kung saan tayo magka-cut? Actually, ang kailangan nyo lang gawin is i-cut nyo sa dalawa yung segment. About any point sa segment, maghati lang kayo or gawa lang kayo ng cut. Example, itong segment na to, hatiin natin sa gitna. Distance x. Ayan na siya. Yung pangalawang segment, ito, hatiin natin sa gitna. And then distance x. Pangatlong segment, hatiin natin sa gitna. Distance x. Pang-apat na segment, hatiin natin sa gitna. Then distance x. So, for us to be able to get the shear and moment equation, you first need to be able to analyze a beam and then distinguish kung ilang segment ba meron dun sa beam na yon. So, how do we know how many segment there is? Ang gagawin mo is you need to check kung saan merong abrupt change or sudden change sa vertical force na present dun sa beam. Okay, so dito meron tayong 4 segments. So we have 4 cuts. Likewise, we will have 4 different equations. Okay, so baka medyo malito pa kayo, no? But later on sa example, mas maiintindihan nyo yung paghanap natin ng segments. Okay, so let's see. Delete this. Check natin. Yan. So, yung shear and moment equation, kukunin natin siya kapag, since di ba naghati tayo, recap, I think siguro na-discuss na sa deformables na, no? Kapag nahati, magdodrawing tayo ng free body diagram. And then, doon natin kukunin yung shear and moment equation. So, the signs of the bending moment, kapag concave upward, it is positive. Kapag concave downward naman, negative. Para mas madaling maintindihan, no? Ganito. Smiley face or ganito yung rotation ng moment. Positive. Kapag sad face, ganito yung rotation ng moment. This is negative. No? Ganito yung sign convention natin for the moment para mas madali siyang memorize. Sorry. Let's see. Yan. So, to plot the shear and moment diagrams, this is written description how to do that. No? Para mas madali, I'll just show you how. Ito. Example tayo para mas madali. So, of course, we have here a beam. Cantilever beam, no? So, kung cantilever beam siya, this is a fixed support. No, di ba ganyan? Very first step in getting your shear and moment equation is to compute first for your reaction. Di ba kapag cantilever, ang support na to is capable of resisting a vertical, horizontal, and a moment. So, siya lang yung magkikerry nung lahat ng force. Okay, so bit of a recap sa reaction natin. 'Di ba? Ang reaction is nagre-resist ng force. So yung uniformly distributed load natin is pababa. So lahat ng to, ang magre-resist lang diyan is yung reaction mo sa taas, pataakyat, sorry. So the total vertical force downward should be equal to the reaction at this point para maging balance sila. 'Di ba? Tulad nung sabi ko earlier, we want the structure or any type of structure to be balanced. So to get the counterpart of this uniformly varying, di ba, to get the concentrated load na represent niya, all you need to do is compute the area. So 0.5. If you have a calculator with you, it's better na para makakasunod kayo. So 0.5, di ba? 1/2 base times height. 0.5 times 30 times 2, this will give you 30. So 30 kips. Now, di ba capable yung portion na to ng vertical force, horizontal, and moment? Horizontal, we don't have any horizontal force present, so wala siyang i-resist to zero. Now, do we have a moment? Of course, we have a moment because this uniform load is, if about this point, no, pwede siya mag-rotate. No? So, may rotation na magaganap. So, of course, we don't want this beam to rotate. Thus, we will have a reaction here, which is your moment. Now, to compute for that, madali lang, di ba? Moment is equal to the force times the perpendicular distance. Na hindi lang yan, this is perpendicular distance or 90 degrees. Now, again, this is just a bit of a recap for your reaction. So, if this is 30, tama, 30 to, no? 30. So, kunin natin tong distance na to. This is 2/3 of 30, di ba? And then, dito sa kabila, this is 1/3 of 30. Now, to get the moment created by the 30, all you need to do is multiply the force 30 times the perpendicular distance, 90 degrees, which is ito. So, the moment is 30 times 2/3 times 30. Okay, so I hope you're following. So, yung moment na create yung uniformly varying is i-clockwise direction na 600. Tama? Ito yung moment na nakikreate nitong uniform varying. Now, since this uniform varying load is creating a 600 moment, of course, this is the same value that should be resisted by the reaction. So, yung moment mo sa portion na to is equal to 600. Yan. So, na-compute na natin yung reaction natin. Vertical 30. No? And then, moment which is 600. So, check natin. Again, this is just a reaction pa lang to. Hindi pa tayo nagkukuha ng equation. So, ni-recap lang natin kung paano mag-compute ng reaction. Yan. So, ito yung reaction, no? 600. Also, mga nakikita kong error, no? Since itong 2 kips fit na uniform varying, no? Again, nag-create to ng clockwise rotation. So, of course, ang reaction mo dapat counter. Kasi nga, ika-counter mo siya. So, 600 plus itong 600 is equal to 0. So, common mistakes kasi, no, lalo sa nagko-compute ng reaction, minsan 600 na yung rotation, mag-a-add ka pa ng 600 ditong clockwise. Kung mapapansin nyo, kung 600 na clockwise yung reaction na nilagay nyo, ito nag-create na siya ng 600, ay umikot na yung beam nyo. Diba? Iikot na siya, wala kang harang. Umikot na siya ng 1,200. So, actually, yung pag-compute ng reaction, hindi lang siya yung sa summation of moment, it equal to 0 kayo basta-basta, no? So, you need to, for a simpler solution, mas magandang ina-analyze nyo mismo yung beam pag nagsosolve kayo. Tapos, direkta na kayo mag-solve sa calculator. Instead of summation of forces vertical is equal to 0, positive upward, di ba? Normally, ito yung way natin na pag-solve ng reaction. Instead of doing this, I suggest na you analyze na lang yung forces sa beam. Kasi mas madali to, no? Pwede kayo mag-solve directly sa calculator na. You don't need to write down the equations. Ang kailangan nyo lang is i-balance yung beam. Dapat lahat ng forces vertical, pag i-add mo 0, lahat ng moment, pag i-add mo 0 dapat. Okay, so yan. Okay, so from here on or onwards, kasi I will no longer be discussing the reactions because I will assume that you already know how to compute for them. Balik na tayo dun sa topic natin, which is your shear and moment. Okay, so ito na yon. Now, how do we know how many segments ang meron sa portion na to? Diba? Again, first step, after nyo makompute yung reaction, itong dalawa, ilang segment ba meron? Now, since this is a uniformly varying, ibig sabihin, dire-diretso naman yung pag-apply mo ng load. No? So, hindi siya nahati sa ibang segment. So, this is just one segment. So, isang cut lang tayo. About any portion dyan, mag-cut ka ng X. So, ito na yung X. So, kunyari ito yung cut mo, no? Kasi isang segment lang naman yan, isang cut lang yung kailangan natin. So, ito yung X. Ito yung one segment lang siya, ha? One segment lang. Paano ba siya magiging two segment? Anong gagawin natin? Para maging two segment siya, kunyari, may concentrated load ka dito na 15. Kapag kasing may 15, makahati yan sa dalawang segment. Now, kapag mahati siya sa dalawang segment, maghahati na tayo ditong X, tapos hati ka ditong X. So, ganun siya yung paghati ng segment. No? Actually, madali lang naman siya. Yan. So, balik tayo. So, we have here a single segment. No? Cut natin X. So, anong gagawin natin pagka-cut? All you need to do is draw the FBD. FBD, let's use the right side or right side of the FBD. No? So, ganito. Kung right side ng FBD, ganitong itsura niyan. Now, meron tayo ditong 30. Then we have here 600. Tapos this is X. Now, again, tulad nung sabi ko, about any point in a beam, we have internal shear and internal moment. Now, since we cut it here, lalabas din yung internal shear, which is your V. And then your internal moment, which is your M. Now, ito yung hinahanap natin, V, tsaka M. Now, ang hinahanap natin is in terms or as a function of X. So, in terms of X lang tayo. So, to do that, wala pa tayong height, no? Ano ba yung height na to? Kasi ito 2 kips per feet. Ito naman, ilan siya? So, how do you get the height here? So, simple lang naman yung gagawin natin. All you need to do is do ratio and proportion. So, rise over run. So, this is 2. Ito na 2. So, 2 over 30 is equal to yung height na to, no? Ito yung hinahanap. So, y all over x. So, yung height natin is y is equal to 2x over 30. So, x over 15. Tama? So, rise over run, 2 over 30, tapos y over x. So, ito yung value ng y. So, pwede mo na siyang ilagay dito. This is x over 15. So, yan. Now, to get the shear and moment, all you need to do is do summation of forces vertical, tapos do summation of moment to get the equation. So, since given na to, kompleto na tayong lahat, mag-summation of forces vertical ka na lang. Equal to 0. Let's assume positive upward. We have first force 30 upward. And then, yung V, in-assume natin na upward siya, no? So, plus V. Minus, yung x over 15 is pababa. Now, since this is uniformly distributing load, uniformly varying load, convert muna natin siya into concentrated load. How do we do that? Again, area. So, 0.5 times x over 15. So, this is 1/2 of the base x. And the height, x over 15. Tama? So, kung isa-solve natin siya, magiging siyang x squared over ano ba yan? X squared over 30. So, minus x squared over 30 equal to 0. So, rewriting now, in terms of v, no? Kasi as a function of x, lagi nang may x dun sa equation natin. So, we have v is equal to negative 30 plus x squared over 30. So, ganun lang yung pagkuha ng shear. Summation of forces vertical lang. Now, for the moment, ganun lang din. Pag-compute ng moment, mag-moment ka lang dito sa portion na to, no? So, summation moment, sabihin natin 0.0. Saan tayo nag-cut? Clockwise positive. So, we have 600. This is counter. So, negative 600. Plus, kasi yung 30 clockwise direction. Dun sa nalilito sa sign convention, no, yung 30 times x, ang rotation niya, no, is pag ganito. This is a clockwise rotation. No, clockwise yan, di ba? Rotate, 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 clockwise. So, pass 30 times x. Ito namang negative x squared over 30, this is counter naman siya, di ba? Yung rotation niya is counter. Ganyan. So, negative x squared over 30. Ang distance niya ay x over 3. Ito. But this is 1/3 of x. So, magiging times x over 3. Yung m natin is clockwise yung assumption ko. So, plus m. Then, rewrite. Okay, so medyo magulo na yung sulat ko. So, lagay natin yung correct. So, in-explain ko lang kung paano siya ginawa. Ayan, no? So, x over 15, yun yung height. Tapos, kunin natin yung equivalent concentrated load. Tapos, summation of forces vertical to get your V in terms of x. Tapos, summation of moment naman to get your M in terms of x. Now, for example, ito kasi ang tanong is a function of x. Pinakamadali is, if ang tanong, kunyari, what is the shear and moment at points, sabi natin this is point ABC, no? ABC. Tapos kunyari, this is 10, kunyari may distance siya, 10 feet. So what is the shear and moment at point B in the beam? So instead of x, gagawin nyo na lang tong 10. So, and then the same procedure. So, it is simpler because wala na tayong constant na x, no? So, masasolve natin siya. Now, yung kagandahan nung ganitong equation, na yung in terms of x, pag kunyari ang dami nung tanong, what is the shear and moment at this point, at 0.5, at 5 meters from the left end, at 10 meters, at 25, at 15, etc. So, if napakarami ng value, all you need to do is substitute those values of x dito to get the value of your shear and moment. Now, if the question is a specific point only in the beam, mas maganda na idirekta nyo na siyang ilagay dito instead of labeling this as x. No? So, mas madali yung ganun. So, kapag ang tanong is specific, change nyo na lang to dun sa kung ano man yung distance na hinahanap. Okay, so yun. Ito naman, draw. I determine the shear and moment in the beam as a function of x. So, first step is i-compute natin yung reaction, di ba? So, again, I will no longer be discussing how the reactions were solved, no? I hope you already know how to do that. Recap lang before. So, 4 times 12 plus 60. So, meron tayo ditong 108. Tapos, kung mapapansin nyo, lahat yan clockwise. So, definitely counter yung reaction natin dito. So, we have 4 times 12 times 6 plus 60 times 20 plus 100. So, this is 1588. So, I hope nakuha nyo yung the same na reaction. Second step, di ba, is we need to know how many segments yung nasa beam. Now, here, since uniform load to, this is one segment. Ayan. Doon naman, pangalawang segment. So, all in all, we only have 2 segments. Please neglect yung mga to. So, dito, meron tayong 2 segments. Kasi ito lang yung hati nung beam. So, therefore, we will only have 2 equations. Una is dito yung cut, distance x. Pangalawa, dito naman yung cut, distance x. So, ganun. No? So, hahatiin nyo lang yung segment. Now, first is, we have, since meron tayong dalawang segment, kailangan nating i-establish yung limit. Yung first nating segment is ito, no? Itong part na to. So, ang distance is 0. Reference mo dito. So, 0. X. Ang limit mo is at distance. This is distance. Ito, distance 12. So, ito yung first limit. Ang pangalawang limit naman is ito ng segment na to, no? So, from distance 12 papunta sa distance 20. So, i-establish lang natin yung limit. So, 12 x. So, ito yung two limits ng dalawang segment. Para mas madali, lagyan tuloy natin ng letter. This is A, B, tapos C. Sabihin natin, this is for segment AB. This is for segment BC. And then, we will now need to draw the free body diagram. So, kung yung segment AB, ganito yung free body diagram, no? Ano ba yan? We have here 108, and then I hope you try to solve the reactions also, tapos paki-correct kung mali yung lagay ko, no? So, this is 4. Tapos, ito na yung distance x. Tapos, similarly, magkakaroon dyan ng internal shear and internal moment. Now, how do we get the value of your V? Summation of forces vertical lang. Summation of forces vertical. Vertical in terms equal to 0. Tapos, yun na, makukuha nyo yung V in terms of X. Then, mag-moment kayo sa point na to. Summation of moment 0. Makukuha mo yung moment in terms of X. So, pakita na lang natin. So, yan na. Ito yung tapos 0 to 12. Ito yung V natin. Ito naman yung M. Now, for 12 to 20, yan. Ito naman yung shear, tapos ito naman yung moment. So, again, ito yung cut natin. No? Also, reminder, because common mistakes din ng students is, di ba, yung pag-convert nito, itong 48 kips, nakikita nyo. Yung pag-convert nito, ito, yung pag-convert nito, we only do this for the sake na makompute natin yung reaction. So, you do not get the, you don't get the equation na kinonvert nyo into a concentrated load, yung uniform load. No? So, kapag kinukuha nyo yung mga equations, no, itong mga equation na to, dapat in terms of the original load, which is the uniform load, not the counterpart na concentrated. Kasi mamamali yung sagot nyo. No? So, yun. Ulitin ko kinonvert lang siya for the sake na makompute natin yung reaction. Mas mapadali. Sinimplify lang natin. So, here pala, pwede kasi isa lang yung reference nating x, pwede din dalawa. Tulad nito, no, instead of just x, ay nakalagay dito is x1, representing the 0 to 12. Ito namang isa is x2, representing the 12 to 20. So, pwede naman na hindi x sub 1, x sub 2. Okay lang din naman na x lang yung lagay yung value. No? As long as you write the limits. Na. Ito lang naman yung importante doon. So, yan. Okay, so I suggest you try to solve this on your own na lang. Itong mga to. So, let's see. Let's have one last example. Lahat pala to cantilever. Okay, so yan. Solve natin muna yung reaction, no? That is 20 times 10. This is 200. Tapos, ang moment niya is 20 times 10 times 5 minus 500. So, 500. So, this, meron tayo dito 500. No, so yung goal nung pag-compute ng reaction is dapat matuto kayo na nagsosolve kayo ng reaction no, without writing the equations. Yung parang titingnan nyo lang yung figure, tapos just use your calculator, mako-compute nyo agad to. So, yun yung goal natin. So, maybe for now, you can't do that. So, practice lang naman yung kailangan yan, tsaka understanding nung beam. So, yun. Ito yung reactions natin. Kinumpute ko siya manually using your calculator. Yeah. So, you may recheck that. Tapos, anong gagawin natin? So, how many segments ba siya? Dalawa ba? Isa? At this point, ilang segment? Meron lang tayong isa. Kasi uniform load naman siya. Wala naman tayong concentrated load para mahati siya sa dalawang segment. So, here we only have one segment AC. Now, kung segment AC, you may no longer write the limits kasi obviously 0 to 10 na yan. Tapos, di ba, hatiin natin siya about any point. Sorry. Dito pala, naka-specific pala yung tanong na, sorry. Determine the axial, shear, and bending moment at point B. So, naka-state sa problem na dito natin siya hatiin sa point B. So, you don't need to write the shear and moment in terms of X. So, mas madali yung ganito. So, first step is draw the FBD. Draw natin yung FBD. Yan. So, this is 20 kilonewton meter. And then we have here 6. Again, yung distance niya na mismo yung gagamitin. Then you have here 200. And then 500. 500. Yan. Tapos kukunin natin yung shear tsaka moment. How do we do that? Tulad ng sample ko, simple lang. Mag-summation of forces vertical kayo. Equal to 0. Assume positive upward. We have upward 200. And then downward 20 times 6. Tapos upward V. So, ang internal shear niya is 200 minus 20 times 6. Sorry. 200 minus 20 times 6. This is 80. Positive 80 transforms to negative 80. Ibig sabihin, anong ibig sabihin ng negative? Ibig sabihin, downward yung shear force natin. Kasi ito upward to, no? Now, since negative, ang ibig sabihin niya lang naman is mali yung assumption mo. So, yung shear natin is downward. Now, for the moment, no, mag-moment lang tayo sa point na to. 0 equal to 0. Positive clockwise. So, we have 200 times 6 minus 500 kasi counter. Tapos yung 20, no, counter din siya. So, minus 20 times 6. Again, itong 20 times 6, yung load pa lang to concentrated load. Ang moment arm niya is half nung 6, which is 3. Ito, concentrated load pa lang to And then, minus M, kasi counter yung aking assumption. So, the moment here is equal to 200 times 6 minus 500 minus 20 times 6 times 3. So, the moment or the internal moment present at point B is equal to 340. Now, if you'll notice, you have here 3 questions. What is the axial force, shear, and bending moment? Ang nakuha natin is shear tsaka moment. Ano ba yung axial force? As the name suggests, axial. It is a force that is in line with the direction of the cross-section of the member. Ang cross-section ng member is ito, no? So, ang inline sa direction na yan is ito po. parallel. So ito yung axial force natin. Now, in this case, we don't have a horizontal force, no? Wala tayong horizontal force. Therefore, your axial force, kasi wala siyang i-resist, na should be equal to 0. Now, kailan siya magkaka-value? It will have a value if, for example, ang load natin dito is ganyan. So, kasi di ba kapag inclined, meron yung vertical tsaka horizontal component. So, ito, i-resist na to agad nito. Tapos magkakaroon din yan ng reaction dito. So, dapat lang malinaw sa inyo yung definition ng shear, axial force, tsaka bending moment. Okay, so I think that's about it. This is your, this is actually yung ginagawa natin. This is a representation of the shear moment and axial forces in a beam. Ano yung 340? Ano yung -80? Ano yung 0? Ulitin ko, about any point sa beam, 'di ba? Tulad ng sabi ko, meron diyang internal forces. So at point B pala, meron diyang 80 downward na shear dito sa point na to. May pababa tayo diyan na 80. Internal force to ha. Tapos meron tayong moment dito. Tapos meron tayong, wala tayong axial force kasi 0. So, anong purpose nila? Ang purpose nila is gawing balance yung system. Kasi eto, kahit hatiin mo siya, pag mag-sum tayo ng forces, 0 pa din. So, no movement na mangyayari dun sa beam. So, the beam is in equilibrium. Okay? So, this is the shear and moment and axial force. Sorry. So, next, we will have the shear and moment diagram. So, dito inuna muna natin yung definition and concept.